Hello everyone. The topic of our group project paper is the impact of international oil price fluctuations on inflation in major oil importing economies, a panel data analysis with exchange rate and industrial activity controls. We are Group D. This is my group members Zhang Yan, Lu Yaling, and myself, Xie Suyi. Next, we will introduce from 7 parts. Firstly, let's look at the objective of the study. In recent years, the volatility of global energy markets has led to sharp fluctuations in international oil prices, significantly impacting major oil importing economies. Rising inflationary pressures have made assessing oil price shocks increasingly important. However, oil prices do not act alone. They often interact with exchange rate movements, industrial production changes, and labor market conditions. Against this background, we realize that oil price movements are not the only factor that affects inflation in isolation, but that it is often accompanied by the linkage effects of exchange rate fluctuations, changes in industrial production, and pressures on the job market. The objectives of this study are therefore threefold. First, we wish to identify, through quantitative analysis, the direct and indirect effects of international oil price volatility on inflation. Second, the 5 countries we focus on: China, Japan, Korea, Germany, and Turkey, whether there are different inflation sensitivities to these macro variables. And third, we hope that based on these empirical results, we can provide relevant policy makers with more informed response strategies and theoretical reference. The next part is brief review of theory. As we know, inflation is a sustained rise in the price level that affects the cost of living of the population and macroeconomic stability. From an economic perspective, inflation is influenced by several key factors. First, rising crude oil prices increase transportation and production costs, leading to higher commodity prices and cost-push inflation. Second, exchange rate depreciation makes imports more expensive, triggering imported inflation, particularly in import-reliant countries. Third, a falling unemployment rate boosts income and spending, driving demand pull inflation. Lastly, rapid industrial output growth may disrupt supply-demand balance, ending inflationary pressure. These 4 variables form the core of the price transmission chain and are included in our model to better explain CPI fluctuations. This modeling approach clarifies how key macro variables relate to inflation, reveals the transmission between cost push and demand pull effects, and enables cross-country comparisons for broader policy analysis. Then comes the third part, data source and sample period. All of our data comes from the IFS. The sample includes China, Japan, Korea, Germany, and Turkey. They are all major oil importers with diverse monetary systems, ideal for cross-country comparison. The monthly data spans January 2030 to December 2022. The variables are defined below. Together, these variables form the basic framework of our subsequent panel model and will be used to estimate the path of various types of macro shocks on inflation. Next up is my team member, Lu Yaling.
Okay, this part I will start with stationary testing and variable transformation. The first variable is international oil price. The log of oil prices is non-stationary. After first differencing, D log oil price becomes stationary according to the ADF test, enabling analysis of short-term price shocks. Next is consumer price index. Given the global interconnectedness and the cross-section dependence among the 5 countries, the CIPS test more accurately captures the interdependence among macroeconomic variables. The log transformed CPI is found to be stationary based on the CIPS test and can be directly included in the panel regression model. As for industrial production index, the original log API is non-stationary. After differencing, D log API passes the CIPS test and becomes stationary, ensuring its suitability for panel analysis. As for exchange rate, the log of exchange rate is non-stationary. After first differencing, D log exchange rate becomes stationary according to the CIPS test, mitigating the risk of spurious regression. As for unemployment rate, the log of unemployment rate shows marginal stationary, with the CIPS statistic close to the 10% significance level, indicating the need for caution and robustness checks during modeling. Next part is model establishment and selection. As for model establishment, this study uses log CPI as the dependence variable and includes D log exchange rate, log in unemployment rate, D log oil price, and the D log API as explanatory variables to construct and compare OLS, fixed effects, and random effects panel regression models. Let's look at OLS model. The log exchange rate and the log unemployment rate have a significant positive impact on log CPI, while other variables are not statistically significant. What's more, R squared is equals to 0.2102, indicating a modest fit. OLS model does not account for unobserved individual heterogeneity. Let's look at fixed effects model and random effects model. The fixed effects model achieves a high explanatory power, R squared equals to 0.8832, with D log exchange rate remaining significantly positive, indicating robust results after controlling for unobserved cross-section heterogeneity. In the random effects model, the log exchange rate and the log unemployment rate have significant positive effects on log CPI, but the overall explanatory power is low. R squared equals to 0.0356, indicating limited model fit and suggesting potential issues with unobserved heterogeneity. Next part is Hausman test. The Hausman test yields a chi-square statistic of 129.3841, p-value less than 0.05, which strongly rejects the non-hypothesis that random effects estimators are consistent. Therefore, the fixed effects model is preferred, as it provides more reliable estimates by accounting for unobserved heterogeneity across cross-section units. Okay, next part will be explained by my group member Zhang Yan.
Okay, thanks, Lu Yaling. This part I will explain model adjustment and robustness check. Here we can say the DW statistics below 2. that indicating strong first-order serial correlation. To improve the robustness and the reliability of statistical inference, we have two steps. The first one is introduce LCPI-1 to model dynamic dependence. Second one is apply the wide cross-section robust to address heteroscalar statistics. This is post-correction results. Here we can say the DL exchange rate, the probability, and the D oil price probability, and the LCPI-1 probability, all below 0.05 is very significant. Here is unemployment rate. Here is employment rate, and the L industrial production index, the probability is more than 0.05. This is the control variable, was not very significant, but we also retained. The DW statistic also significantly better than the original one. This is our group, the equation. From here, we can get the equation. From that, so we know that the oil price and the exchange rate. Oil price, here is the oil price, and here is the exchange rate in the equation. Is very shocked are key inflation drivers, which means exchange rate depreciation raises CPI, and the oil price increases push up the CPI. Here is our group, the suggestion from this research. The first one is enhance exchange rate stability. The exchange rate stability helps mitigate imported inflation, especially in import-dependent economies. Second one is preemptive inflation control. Due to inflation inertial, early intervention is crucial to prevent worsening inflation dynamics. Third one is diversify energy structure, reduce oil dependence through alternative energy, and improve the efficiency to contain cost push inflation. The final one is monitor labor and industrial indicator. Continue tracking the L unemployment rate and the DL industrial production index for lagged or non-linear inflation effects. Refine model accordingly. Okay, thanks. I sincerely thank the professor for your time and attention. Our group welcome any questions, comments, and suggestions to further refine this research. Thank you.